So hello guys, welcome back to my channel Krishna Programming number one. And guys, in this video I'm going to show you guys how you can make your own frequency generator. Okay, so like from this video you will be able to learn if you want to generate some frequency using your Arduino, you don't need any external library. I will tell you how to just generate it and everything. Like we are going to make a proper frequency generator. It can generate a maximum of 1 megahertz frequency signal. Okay, so let's start. First let me tell you basics of it. Okay, so here in MS Paint I will show you. So as guys, if you don't know, I'm gonna explain you what is the how to calculate frequencies, like how we will generate it. So if you don't know, let me tell you the formula of frequency. It is equal to 1 upon time. Frequency equals 1 upon time. Okay, and that frequency is pretty easy. Like this is a, I'm just making a diagram. Okay, so here uh will you able are you able to see something? So this is a PWM signal, pulse width modulation. I have explained this in some of my previous video. So this is a signal. Okay, and so what you are seeing here is this part. So this is called as space width. I'm calling this as SW space width, and this is called as PW pulse width. Okay, and then guys, this time is equal to pulse width plus space width. Okay, and this guys, this is the time when the signal is on, like plus 5 volt, and this is the time when the signal is off, like 0 volt signal ni voltage. Okay, so 5 volt, 0 volt, 5 volt, 0 volt, any voltage it can be. So this can be on a graph. Okay, uh, as you can see. So here this is the time axis, y time, y-axis, x-axis, and this is time and this is voltage. Okay, V voltage. This is maximum. Here is 5 volt. Here is 0. So guys, this pulse width, like I'm gonna show you pulse width first of all. So like your signal is on for about 0 point like 2000 millisecond, and then it was off for around 200 millisecond. So then this would also be equal if the it is a continuous signal. Okay, so here as you can see, so this, then the time would be how much? Like your duty cycle of your PWM signal is 2000 millisecond, or like 1 second is equal to around, not around 1000 millisecond. Then 2000 millisecond is equal to 2 into 2000 divided by 1000 second, so which is equal to 2 seconds. Okay, so our signal is on for 2 seconds, and then it is off for 2 millis 0.2 second. Then 1 upon pulse width plus space width is our formula. So this is equal to frequency. Then the frequency of our signal guys would be equal to around like frequency equals 1 upon time, which is equal 1 upon PW plus SW, which would be equal to 1 upon 2000 plus 200 whole divided by 1000, and which would be also equal to 1 by 2 200 by 1000, which would be equal to 1 by 2.2, which would be equal to 1 by 2.2, right? Let me calculate. 1 by 2.2 will be equal to 0.45. So this is the frequency of this signal. Okay, so this is the signal that you are seeing here. The frequency of this signal is let me just, this is the frequency of this signal. Okay, so guys, with the help of this diagram and with the help of this understanding, this is basic physics, we are going to make a frequency generator. Okay, so as you may know, it is pretty easy. So let's get on to the code. Okay, so here I'm first gonna show you the main thing. So first we are going to initialize some variables here. First let me make the setup loop, and after that void loop. Let us name something this project like RDFGen, Arduino frequency generator. It's nice. Okay, so now let's say int out pin, output pin of the Arduino would be 7. Then let's say floating value should be there. Okay, like because we are going, our time can be floating, like 2 point something seconds, and so like that. Float time is equal to 0.00, and float pulse width equals 0.00. You know, I explained you pulse width. For here let me write equals 0.00. Let me say here that time equals pulse width plus space width, and then floating normal pulse width. Okay, sorry, uh, like pulse width in microseconds variable. So like this would be equal to 1 microsecond is equal to 1 upon 1, 1, 2, 3, 4, 5, 6 seconds. Okay, comma, because 1 second is equal to 10 raised to the power 6 microseconds. Okay, so let me just save this RDFGen. So then our second part of this would be space width in microsecond. Just we are going to get the value from our Arduino in microsecond, then we will convert it into normal seconds, then we are going to calculate the time in seconds, then we are going to calculate the frequency in hertz, kilohertz or megahertz. Okay, so like, you know what is oscillation? Frequency is related to oscillation. So wait, my computer lagged, I think. Yeah, my computer, it's back. Okay, float space width in microsecond is also equal to 0.00, and then we have float frequency. Done. Then like we are going to say our serial a new name. So this we are going to define UART as serial. Okay, so like this means like if we say is UART dot print. Okay, so if you say hello, it would be equal to serial dot println. Like wherever in the code you write UART, it would be equal to serial because we defined UART as serial. So now we are going to start our setup. Okay, so in the setup function, let me just show you. Here in the setup function, we like what we'll do, nothing. Okay, we're going to do nothing in setup, just UART dot begin 115200 at this baud rate. And after that, what we gonna do? Like guess something. Write in the comments down below what we are gonna do next in 5 seconds. 1, 2, 3, 4, 5. Over. So guys, here we're gonna write here one more line. Print ln welcome to our gen. Okay. So then here we are gonna say if UART dot available, like basically we are going to get commands from the user from serial monitor. Okay, if UART dot available, अगर हमारा UART available हुआ, then we are gonna get message from it. Input would be equal to UART dot read string. Okay, we are going to read the input data as a string from the serial monitor by the user. Then we are going to trim the extra thing left. Sorry, input dot trim, like the waste material we are going to trim from the string. Okay, and after that we are going to get like say if else statement, like if the command equals this, then do this thing. If then, okay, this thing, like if input dot equals, if input dot equals we are going to say command set pulse width. Okay, is it nice? Set pw. Okay, then in set pw we are going to say UART dot println we are going to print enter pulse width in microseconds. Okay, so it would be a print line, because if we do print ln, then the entered data by the user will show in next line. Okay, if we do the printing command, so it should be in the same line, so we use print. Let's wait for the user to enter. So while the data is not available to us, we are going to do nothing. When the data comes, okay, when the data comes, then we are going to say int get pulse width equals UART dot parse int. Okay, we are going to use this parse int function to get the integer value. Then pulse width microsecond equals GPW. Okay, GPW. Then pulse width would be equal to GPW divided by 10 raised to the power 6. Let's say directly 1, 2, 3, 4, 5, 6. Done. Then time would be equal to pulse width plus phase width. Then frequency would be equal to 1 upon time. Okay. Then we are going to say UART dot print line our p pulse width in microseconds. Then UART dot print, no, wait a second, let's enter some more lines after it. Here will be line ending dot print this much microseconds. Okay, so after this part we are going to say UART dot print pulse width in seconds of your signal equals pulse width in microsecond divided by 10 raised to the power 6. We are going to give some calculation to the user, which would be equal to ur dot print pulse width normal one. Then we are going to print ln this much seconds. Done. This part is done. Okay. Space width 1. Then we are going to just copy this, paste it, set space width, enter space width in microsecond, get swg pcos. We are going to just set a pw to gw, and pulse width we are going to replace with the space width. Okay, I think it's done. SW space width GSW GG. Okay, done. This one also done. Then after this, guys, we are going to say initialize the signal. Okay, to initialize the signal, we're gonna say a new if statement. Let's just paste this, remove this thing from it. Says init. So our output pin is 7. Then it would say ur.println initializing. Okay, wait, guys. Okay, initializing your signal on digital pin digital pin D out pin, right? Yeah, out pin initializing your signal on digital pin D7 with, we are going to just now say the user everything. Okay, with frequency ur.print frequency ur.print. This is just like we are going to inform the user that it is going to initialize with this much frequency on this pin, how much pulse width, how much space width. Okay, so this much frequency. In like now we are gonna make a function. Okay, here with frequency, if frequency is higher than 1000, higher than or equal to 1000, then we are going to see if frequency is higher than or equal to this much, right? Let's say 1 mega. Okay, 1 mega equals 1 mega equals 10 raised to the power how much? Okay, mega is 10 raised to the power 6. Okay, 6 times 0, 1 2 3 4 5 6, higher than or equal to this. Then we are going to say int new frequency, nf we are going to define as new frequency equals frequency divided by 1 1 1 2 3 4 5 6. Okay, So guys, after this we are going to say yeah, NF. Then if, sorry, else it just have to say int else int nf equals f upon 1 1 2 3. Alright, done. So this is it. Else int nf equals f. Done. Print nf uart dot print this only. If frequency equals int nfs and a new frequency string, okay, like new frequency unit, let's say, equals 1 equals 2 equals 3. Okay, so guys, here what it will do, it will say uart dot, no wait, here only we will print it, uart dot print wait a second, why the hell are we even doing this, right? We can just remove this. We can use we are noobs, guys. Yeah, here we can do it. Nf equals frequency upon this nf ur dot println. No, what we're gonna do guys here, we are gonna just say to print it like normal. Okay, so print space megahertz. So same here, kilohertz, and here hertz. Done. After this we are gonna make a new function called as init signal. So this is our function name. Let's say the function here initialize signal. Okay, now initialize signal is pretty easy. It's really easy. Okay guys, digital, first we in this also ur dot begin, we are gonna say digital write out pin comma output. Done. After this we're gonna say, oh, not digital, right, pin mode, digital write out pin comma high. It would be like, according to this, it should be high for pulse width time. Okay, pulse width time, it should be high in delay micro seconds for PWUS, yeah, and then it should be low for space width. Okay, space width time. So here we're gonna say it should be low for space width microsecond time. Done. Boom. Here we go guys, and our project is done, I think. Yeah, it's done. Let's just add one more command here. In that command what we gonna say, show data. Okay, show data. So in show data it is going to show us everything, frequency and everything. Okay, println. First it is going to show us pulse width in microseconds. Okay guys, pulse width in microseconds. Then ur.println pws. The same for space width. And now for frequency, we just gonna take this frequency. This is the function. Let's go. It's done. So guys, now we're gonna test it on our Arduino Duo. Let me just upload the code. So guys, sorry for one thing that I will not be able to show you the hardware image because I don't have a camera right now, but I'm damn sure it will work. Any errors that will come now, I will solve it. So I'm gonna pause the video guys till till the uploading completes. Okay, so guys, here as you can see the program is uploaded. It's uploading now. Uploaded. Yeah, welcome to RDFGen. Let's go. And here if we write the command, what was the command? Show data. Then it is going to show this. Let's go. Now if we say set pulse width in microsecond, I say this much. For your signal will be 0.00 only, because guys there should be 3 more zeros to show the exact thing. Okay, now if I say show data pulse width in microsecond, yeah, it counted, and then the frequency is this. Oh my gosh, megahertz. Then if we add a space width, let's add it. uh, Space width set sw, right? And the space width would be same as pulse width. Then we say show data. As you can see, both are equal, but the frequency is not working. We are having some problem here. So the way it calculates frequency, let's just say to write the frequency in hertz only. Frequency equals 1 upon time. Yeah, everything is fine. Nothing's wrong here. Let's see what is wrong. Oh, I didn't realize the. Wait, I know. Let's just write normal frequency in hertz. Frequency F. Here also we are gonna say it. Write the frequency F. I don't know what problem it is. So wait a second, guys. Yeah, guys, I'm back. I was having some work. Okay, so now it is going to print the normal frequency in hertz in its signal. Yeah. Show data. It should be fine. Let's go. Upload the code. Yeah. So guys, basically, did you understand this diagram? Write in the comments down below right now. In 3, 2, and go right down. I did the old comment that you did, and in that only write. So as you can see, the code is uploading. Okay, let's say set pulse width this much, set space width this much. I will say show data infinite. What is this, guys? We are having some problem to calculate it. What it can be? What it can be? Why is it showing? So guys, do you have any reason for it? Like why is it showing this infinite? Oh, sheesh. In the code, I think I did a big mistake. So guys, did you realize the mistake? Tell me guys, did you realize the mistake? I didn't realize the mistake. Let me see here. 6 zeros tell. 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2. Okay. Alright, so second, guys, like, what is the problem? Oh, sheesh. No problems. Let's say what we written there. Type in Google. What was our frequency there? Here, like if I say our frequency was frequency equals 1 upon time. Okay, time equals PW plus SW. Our PW was 0.0001. SW was also equal to 0.001. Then frequency would be equal to 1 upon 0.0001 plus 0.0001. Then frequency would be equal to 1 upon 0.0002, right? Then frequency would be equal to 1 upon, no, frequency would be equal to like 1 upon 0.0002. 5,000. It would be equal to 5,000 hertz, and then frequency would be equal to 5 upon 5,000 upon 1,000 kilohertz. Then frequency would be equal to 5 kilohertz. This should be like correct thing, but it's not. RDK, what is happening? So let me just fix the problem, guys. Return, and I'll return you to back. Okay, guys, wait some time. So guys, I fixed the error. The error was pretty dumb. We were just dividing second by 1000, okay, and then we have to divide microsecond by 1000. So I replaced that GSW, GPW by this in same as in pulse width, and I uploaded the code. And now if I say set pulse width like 1000 microsecond, and then set space width 1000 microsecond, then if I say show data 500 hertz, yeah, it works. And if I say set pulse width 1 microsecond, then if I say uh, show data, yeah, let's go. And then if I say show set SW 1 show data, oh, as you can see, pretty nice. It's half a megahertz. It's equal to 5000 kilohertz. Now here if I say set SW 0, then if I say show data, yeah, 1 megahertz maximum frequency. So guys, this is it. Now if I say init signal, what was the, okay, it was init only, init, yo, let's go. And guys, I'm damn sure it works because you know this logic. It's pretty simple here. It does just delays, so it does work. Sorry for that. I can't show you the video because I don't have a camera. So guys, I will give you the full completely nice code with the display 20 by 4 LCD support, okay, and this raw code also, okay. So guys, I hope you like this video. If you like this video, subscribe to my channel. Thanks for watching. Stay safe. Bye bye. Stay creative also.